Welcome to 7.2. We're solving trigonometric equations. So we want all the solutions of this equation. So the question is, where does y equal negative square root 2 over 2? Okay, so it is negative. Okay, if you think about this in a unit circle, negative is down in the third and the fourth quadrant for y. So where is your value of negative square root 2 over 2? Well, it's at your 45s. So you have 3 pi over 4, and you also have, 5 pi over 4 and 7 pi over 4. Now, all solutions means how many forever and ever and ever as you go around. So if we go around to 5 pi over 4, we can add another 2 pi. We can add another 2 pi and another 2 pi. So how we write that is, our answer is 5 pi over 4 plus 2 pi n for how many times you're going to go around. And the same thing for the 7 pi over 4 plus 2 pi n. All right, now cosine, where's the x value? Negative 1. Well, negative 1 for x is right here. That's at pi. So pi plus 2 pi n. Okay? Number 3. Now we have tangent theta. So where is it? The square root of 3. So remember, if we look at it as a fraction and we put 2's underneath everything, that's where we get our x and our y. So where is the tangent of theta? The square root of 3. Well, the y is the long leg, and x is the short leg. So long leg is y, x is the short leg, and then also in 180 degrees in the other direction. So the first thing is, what is that one? So that's 60 degrees, which is pi over 3. And if we add another pi to it, we get to the other one. Well, if we just keep adding so many pi's to each one, we hit both points every time. So when you have tangent and cotangent, you're really dealing with 1 pi times n, depending on what it is you're looking at. So cotangent, again, should be plus pi n, depending on certain things. So we'll keep an eye out for the differences. So again, put a 2 underneath each thing. And so you have the short leg. It's negative, first of all. So x over y is cotangent. So you're looking at the second and third quadrants. X is the short leg, y is the long leg. So again, you're looking at these two values. So that's going to be 120 degrees, or 2 pi over 3, plus the pi times n. And that gets both. That gets all the way to here too, and then it just keeps going around and around and around. Okay, now secant is 1 over the cosine. Okay, so it's still the same thing. Cosine of 1 over cosine of 2, or you're going to say the cosine of beta is the reciprocal, so 1/2. Where's x? 1/2. Okay, x is positive 1/2 right here and right there. So that is pi over 3 and 5 pi over 3. And you got to go around 2 pi infinitely many times. 2 pi times however many times you're going around. Now cosecant is 1 over sine, so the reciprocal is going to be 1 over the square root of 2. All right, which ends up being square root of 2 over 2. So where's y positive? It's going to be there and there. So that's pi over 4 plus 2 pi n and 3 pi over 4 plus 2 pi n. All right, again, where's y pi over 2? Okay, so we're looking at where is sine of x equal to 90 over 2, or 3.14 over 2. So this is a radian measurement, which is bigger than 1. And if you understand your trigonometry, x and y can't be bigger than 1. It has to be less than or equal to 1. Your unit circle only goes to 1. Tangents can be different. Okay, so now here we got cosine. Again, 3.14 over 3 is still bigger than 1. So these are both no solutions. So anytime you're taking this tangent and sine and cosine, and it equals something bigger than 1, it's going to be an error on your calculator. Okay, so now we're getting into the solving of your trigonometric functions. So we have the cosine equal to the cosine. So where is cosine going to be equal to the cosine? So that would be all values, okay, except, remember, you can't have 0 in your denominator. So where is the cosine 0? The cosine is 0, okay, so where's the cosine 0? At pi over 2 and 3 pi over 2. So since those are 180 degrees apart, we'll just say except pi over 2 plus pi n. 180 degrees will get you to 3 pi over 2. So the problem with this one is it seems like everything works except you have the secant in your denominator. Okay, all right, so now you have cosecant, which is 1 over sine times the sine, okay, of theta. So what values of theta make this 1? Okay, so every value except for when your sine is 0. So where is the sine value 0? Sine is 0 at pi and 0. So we're going to do pi plus pi n. 2 cosine 2 theta minus square root of 3. So now let's start to solve. We'll add square root of 3. So 2 cosine of the double angle equals the square root of 3. We divide off the 2, which is that coefficient. So the cosine of the double angle is the square root of 3 over 2. So how do you solve this? You solve as if it was the cosine of, we'll say cosine of x. We'll say let x equal 2 theta. So where's the cosine of x equal to the square root of 3 over 2? That's your long leg. So 30 degrees, which is pi over 6. Okay. So, and then also down here at 11 pi over 6. All right. But now what is our answer? So we have pi over 6, and this is what x equals. And x equals 11 pi over 6. But x is 2 theta. So 2 theta equals pi over 6. And 2 theta equals 11 pi over 6. And how do we solve for theta? By dividing off the 2. Okay, which is like multiplying by 1/2. So that'd be pi over 12. And this would be 11 pi over 12. And then here plus 2 pi n. So you solve it like normal, and then you have to divide off that coefficient on your value there. So we're going to subtract the square root of 2 and divide off 2. So the sine of let x equal 3 theta. Sine of x equals negative square root of 2 over 2. So whereas sine represents y, so where's the y value? Negative square root of 2 over 2. Okay, that's going to be in the third and fourth quadrants at 5 pi over 4 and 7 pi over 4. So now you have x equals 5 pi over 4 and 7 pi over 4. So we have to set 3 theta equal to those. Okay, but remember this is plus 2 pi n. And I see I didn't do that over here. So really you should have divided these total down here by 2. So this answer on number 11 should be pi over 12 plus pi n and 11 pi over 12 plus pi n. So in this one, when we divide off the 3, you got to divide everything. I can't believe I didn't do that, but there you go. So our answer truly would be, if you're dividing by 3, it's multiplying by 1/3. So 5 pi over 12 plus 2/3 pi n and 7 pi over 12 plus 2/3 pi n. Okay, so now let's solve this. Let's divide off the square root of 3. So the tangent of 1/3 t equals 1 over the square root of 3. Again, we'll just say that's, let's just call it something different. The tangent of beta, okay, equals 1 over the square root of 3. So beta equals 1/3 t. All right, so now where does the tangent equal 1 over 3, square root of 3? So divide them by 2. So you have a short leg over a long leg. Okay, so tangent is y over x. So y is the short leg and x is the long leg. So you have pi over 3. And you also have pi over 6, 7 pi over 6 over here. So our answer should be 1/3 t equals pi over 6 plus pi n. Remember, tangent, cotangent is just, they're 180 degrees apart, so you just need to add pi. And that gets you your 7 pi over 6. So I don't need to write the 7 pi over 6 on here. But the issue is I need to multiply by 3. Everything gets multiplied by 3. So now t equals pi over 2 plus 3 pi n. And number 14. So let's let beta equal 1/4 x. All right. So the cosine of beta is equal to a negative square root 2 over 2, which is a pi over 4 function. It's negative. So where's x negative? That's going to be in the second and fourth quadrants. So you have 3 pi over 4, and you have second and third quadrants, 5 pi over 4. Again, plus 2 pi n plus 2 pi n. But that's what x equals. So now we have 1/4 x equals this. So we multiply everything by 4. Okay. And we get 3 pi plus 8 pi n. And we get 5 pi plus 8 pi n. So those are your values for 14. All right. Now we have this crazy thing. So this is just like saying sine of beta equals 1/2. So where's the y value equal to 1/2? Positive short leg. So that's in the first and the second quadrant where y is positive. Okay. That would be pi over 6 and, pi over 6 and 5 pi over 6. So we have theta plus pi over 4 equals pi over 6 plus 2 pi n. And we have theta plus pi over 4 equals 5 pi over 6 plus 2 pi n. So now we're going to subtract pi over 4 to this side. So the first one here, we have theta equals pi over 6 minus pi over 4 plus 2 pi n. And then we have theta equals 5 pi over 6 minus pi over 4 plus 2 pi n. Common denominator is 12, multiplied by 2, multiplied by 3. Same thing down here. So on the top, we get 2 pi over 12 minus 3 pi over 12, which would be negative pi over 12 plus 2 pi n. On the bottom, 10 pi over 12 and 3 pi over 12. So 10 minus 3 is 7 pi over 12 plus 2 pi n. All right, so those are your answers for number 15. 16, same thing. The cosine of beta equals -1, whereas x equals -1. X is -1 right here at pi. So you have x minus pi over 3 equals pi plus 2 pi n. So we're going to add pi over 3 to the pi, and here plus 2 pi n. Common denominator is 3, so we multiply by 3. So 3 pi plus pi is 4 pi over 3 plus 2 pi n. Okay, so now we just sit there and say that 2x minus pi over 3 is your beta. So the sine of beta is equal to 1/2, or where's the y equal? Positive 1/2. So again, you're looking at pi over 6 and 5 pi over 6. Okay, so the 2x minus pi over 3 is equal to the pi over 6 plus 2 pi n. And we'll go ahead and solve that one first. Okay, so let's add pi over 3 to this side. And we get 2x equals, got to get a common denominator, multiply by 2. So pi over 6 plus 2 pi over 6 is 3 pi over 6, or pi over 2. And now we have to divide everything by 2, which is really multiplying by 1/2. So that's pi over 4 plus, in this case, pi n. And then we have to do the other one, 5 pi over 6. So 2x minus pi over 3 equals 5 pi over 6 plus 2 pi n. So we add pi over 3, which is really adding 2 pi over 6. So 2x is equal to 7 pi over 6 plus 2 pi n. And dividing everything by 2 is like multiplying by 1/2. So we get 7 pi over 12 plus pi n. And those are your values for number 17. 18. Again, we'll separate that and we'll just say it's theta. So where does the x value equal pi over 2? Square root 2 over 2, that's pi over 4. Remember, those are pi over 4 values, and it's positive, so x is positive in the first and fourth quadrants. So pi over 4 and 7 pi over 4. All right, so we have 4x minus pi over 4 equals pi over 4 plus 2 pi n. Add pi over 4, and we get 2 pi over 4, which is pi over 2. And then we divide by 4 or multiply by 1/4. So x is equal to pi over 8 plus pi over 2n. And then the other one, 7 pi over 4. So 4x minus pi over 4 equals 7 pi over 4 plus the 2 pi n. So we add pi over 4. And we get 8 pi over 4, which is 2 pi plus 2 pi n. That's 4x. Divide by 4 or multiply by 1/4. And you get x equals pi over 2 plus pi over 2n. All right. 2 cosine of t plus 1. So subtract 1. Divide off the 2. So where's the cosine of t equal to negative 1/2? The short leg. So negative. So that's going to be at 2 pi over 3. And also negative at 4 pi over 3. So what's our answer? 2 pi over 3 plus 2 pi n. And 4 pi over 3 plus 2 pi n. Number 19. Add 2 and divide by 4. So the cosine of theta is 2 over 4, or 1/2. Positive 1/2. So again, we're at pi over 3 here. And x is positive down here at 5 pi over 3. So theta equals pi over 3 plus 2 pi n. And theta also equals 5 pi over 3 plus 2 pi n. All right, so now subtract the square root of 3. So 2 sine of beta is equal to negative square root of 3. Divide off the 2. Sine of beta is negative square root of 3 over 2. So the y is negative in the third and fourth quadrants, and square root of 3 is the long leg. So these are the values where y is the long leg, 4 pi over 3 and 5 pi over 3. So 4 pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n. Okay, number 22. Divide off the 2. Cosine of x is the square root of 3 over 2. So cosine is positive in the first and fourth quadrant, and it's the long leg. So we are at pi over 6 and 11 pi over 6. So pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. All right, now we have two possibilities here. A times b equals 0, so either a is 0 or b is 0. So what does that mean? There's a, this is b. So cosine of theta minus 1 is equal to 0, or sine of theta is equal to 0. So you got two possibilities here. So we add 1, where's the cosine of theta equal to positive 1? That would be at 0 or 2 pi, so we just say 2 pi n. And where is the sine value equal to 0? Where is y 0? Y is 0 at 0 and pi. So it would be pi plus 2 pi n. Okay. So it's just for you to understand, it's in those positions. So actually it's just, you just need the 1 pi. So pi n. So it's every 180 degrees. Cosine is positive 1 only at that position. So that's why it's every 2 pi n. All right, 24, same type of thing. Sine of t minus 1 is equal to 0, and the cosine of t is equal to 0. So where is the sine of t equal to positive 1? Where is y1? Only right there. So this would be pi over 2 plus 2 pi n. Cosine of t, where is x 0? X is 0 at pi over 2. It's also 0 at 3 pi over 2. So since they're 180 degrees apart, we just say pi over 2 plus pi n, not 2 pi n, because it's every 180 degrees. So those are your values. 25, take the square root, and we get the tangent of x equals plus or minus 1. So where's the tangent of x? 1, and where's the tangent of x? Negative 1. Well, those are in those positions where it's 1 and negative 1 in these positions on the unit circle, okay? So those are all your pi over 4s, and they are 90 degrees apart, if you think about it. So really, if we just did pi over 4 plus pi over 2n, we would get all of those answers. All right, and now we do the same thing, add 1, and the cotangent squared equals 1, square root. So again, the cotangent here is plus or minus 1. So it's the same type of thing. Where's the cotangent? That's x over y. Again, it's going to be the exact same thing as what we have on number 25. All right, secant squared, add 4. So the secant squared equals 4. Take the square root, and you get the secant equal to plus or minus 2. Or cosine of theta, or alpha, whatever it is equal to plus or minus 1/2. Okay, so now, where's x? Positive 1/2. That's the short leg, so that'd be here and there, okay? So those are your pi over 6 and 10, let's see, pi over 3 and 5 pi over 3. And then negative 1/2 would be right here. So the other pi over 3s, 2 pi over 3 and 4 pi over 3. Now these are not 90 degrees apart, but pi over 3 and 4 pi over 3 are 180 degrees apart, and 2 pi over 3 and 5 pi over 3 are 180 degrees apart. So all you have to do is do the pi over 3 plus, not 2 pi n, just pi n, and then do 2 pi over 3 plus pi n, and that covers all of them. Now we subtract 3, or we could just add, let's just do this. Let's add tangent over there. So 3 equals the tangent squared of beta. Just so everything's positive, it's the same thing. So tangent squared of beta equals 3. So now we take the square root, and where is the tangent of beta? Plus or minus the square root of 3. So again, if you put 2's underneath that, then you see your y and your x. So we're looking at negative square root of 3 over positive 2. 2 and 1/2, sorry. And positive square root of 3 over 2 and negative 1/2. So the negative could be in either place, okay, for your negative. But then when you're positive, you have positive on the top and positive on the bottom, but you also could have negative on the top and negative on the bottom for your y and your x. So there's 4 possibilities here. So the first one, when y is negative and x is positive, that puts you here at 5 pi over 3. And then the next one, the y is positive and x is negative. X is negative, y is positive, still a long leg. That's your 2 pi over 3. And then you have these down here when they're both positive. That's right there. And the negative negative puts you right here. And again, it's the same thing as what you have on this other side. There's your 180 degrees. So these answers are the same as what we had in 27. All right. cotangent squared of x equals 3. Add 3 to the other side, take the square root. So where's the cotangent of x equal to plus or minus the square root of 3 over 1. So cotangent is x over y. So you still have square root of 3 over 2, 1 over 2. That's for positive, but also the negative of that. And then negative over negative. And then for negatives, one has to be negative, and one has to be positive, and one has to be positive, again, switching it, and one has to be negative. So those are the same. So you have 4 possibilities. So now it's a little bit switched. Instead of pi over 3, your x is your long leg, and your y is your short leg. So now we're dealing with the pi over 6 values. And then if they're both negative, that's over here 180 degrees. So pi over 6 plus pi n, because 180 degrees hits that other one at 7 pi over 6. And then we have a negative x, long leg, and short leg, positive for y, that would be 5 pi over 6. And then a positive long leg for x and a negative short leg for y gets us to 11 pi over 6. So we'll do, 5 pi over 6 plus pi n. Those are 180 degrees apart. So that's your answers for cotangent. All right, add 3. Sine squared of x equals 3, divide by 4. Sine squared of x equals 3/4. And then we take the square root, and the sine of x is equal to plus or minus the square root of 3 over 2. So where's y? Positive and negative long leg. So that's there, there. Those are both positive. Then you have the negative y value being the long leg. So again, those are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And they're 180 degrees apart. So do the first one, pi over 3 plus pi n, and 2 pi over 3 plus pi n. All right, 31. So again, a times b equals 0. So either a is 0 or b is 0. So 2 problems in one here. Okay, so 2 cosine of theta plus 3 equals 0. All right, so let's solve the first one. So we're going to subtract 1, divide off the 2. So the sine of theta is equal to negative 1 over 2. So where's y? Negative 1/2, the short leg, here and there. Y is negative. So 7 pi over 6 and 11 pi over 6. And since they're not 180 degrees apart, sine is every 2 pi. Same thing with the cosine. Subtract 3 and divide by 2. So where's the cosine of theta equal to negative 3/2? This is bigger than 1, so it's not possible. Okay, so the same thing here. We're going to add 1 and divide by 2. So the sine of u is equal to positive 1/2. So the y is positive here and there. So those are pi over 6's plus 2 pi n, and 5 pi over 6 plus 2 pi n. Okay. Now we add a square root of 2, so the cosine of u is equal to the square root of 2, which is 1.414. That's bigger than 1, so not possible on that side. All right, so here, cosine of x plus 1 is equal to 2 sine squared of x. So somehow we're going to have to manipulate this. Sine squared of x is 1 minus cosine squared of x. So we're going to distribute cosine of x plus 1 equals 2 minus 2 cosine squared of x. So let's move everything to the left side. So we get 2 cosine squared of x, and you have a plus 2 cosine, plus 1 cosine of x. That's this one right here. And then we subtract the 2 from the 1, we get minus 1. So it's a trinomial. So we get 2 cosine of x and cosine of x. And 1 and 1. One has to be positive, one has to be negative. So again, that's your negative cosine of x. And the outside is 2 cosine of x. So negative 1 plus 2 is 1 cosine of x, positive, which is what we have right there. So there's your factoring, and now you have your a times your b. So 2 cosine of x minus 1 equals 0, and cosine of x plus 1 equals 0. So add 1, divide by 2. So where is x? Positive 1/2, right here at pi over 3, and down here at the bottom at 5 pi over 3, plus 2 pi n, plus 2 pi n. Those are your two answers for the first part. Second part, subtract 1, cosine of x equals negative 1. So where's x negative 1? Right here at pi. So that's pi plus 2 pi n. All right, 34. Cosine squared. Since we have just sine, I can't change that, but I can change cosine squared into 1 minus sine squared. Plus sine equals 1. So distribute, you have 2 minus 2 sine squared plus sine equals 1. I don't like a negative leading term, so I'm going to move everything to the right. So 0 equals 2 sine squared plus, that'd be minus this sine right here. We got to move it over. And then we have a positive 1, and we're going to subtract this 2, which will give you negative 1. All right, so it's the same type of thing. 2 sine and sine. And 1 and 1. 1 has to be positive, 1 has to be negative, but you need a negative 1 in the beginning. So the outsides give us the negative 2. The inside gives us positive 1. Negative 2 and positive 1 is negative 1. So now you set these both equal to 0 and solve. So subtract 1 and divide by 2. You get negative 1/2. So y is negative 1/2 here and here. So those would be 7 pi over 6 plus 2 pi n. And the other one is 11 pi over 6 plus 2 pi n. And then we add 1 to this side. Sine equals 1. Sine equals 1 right here at pi over 2 plus 2 pi n. So you should have all three of those. All right, 35. So we have two things. There's your a and your b. So sine of 2x equals 0, or cosecant of 2x minus 2 equals 0. Well, again, that's a double angle, so let's just tell me first what the sine of beta equals 0. Where's y equals 0? Y equals 0 here and here on the unit circle. So 0 and pi. So if you do pi plus pi n, or just pi n would be part of your answer. That would be your answer, except beta, remember, is 2x. So 2x equals pi plus pi n. Divide off the 2, and you get x equals pi over 2 plus pi over 2n. All right, so it's going every 90, so you just do basically pi over 2. And the cosecant is 1 over the sine of 2x. 2x should be at the bottom here. We'll just call that beta eventually. Minus 2 equals 0. So 1 over the sine of beta is equal to 2. So the sine of beta is equal to 1/2. So where is y equal 1/2? Right there and right there, positive 1/2. So this will be beta equals, so beta is 2x, so 2x equals your pi over 6 plus 2 pi n. And we divide by 2 or multiply everything by 1/2. So x is equals pi over 12 plus pi n. And it's also equal to the second part, 2x equals 5 pi over 6 plus 2 pi n. So we divide by 2, and we get 5 pi over 12 plus pi n. So those are your answers for 35. 36. So the cosine of 2x equals 0, and the secant 2x plus 2 equals 0. So we'll just say the cosine of beta equals 0. Where does x equals 0? X equals 0 at pi over 2 and 3 pi over 2. So that would be at pi over 2, beta is 2x, equals pi over 2 plus pi n, since they're 180 degrees apart. Divide by 2, and x equals pi over 4 plus pi over 2n. And then 36, secant is 1 over cosine of 2x plus 2. So we're going to subtract 2. So 1 over the cosine of beta equals negative 2. So the cosine of beta is equal to negative 1/2. Where's x negative 1/2? In these positions there. So those would be, let's see, beta is 2x, so that equals 2 pi over 3 plus 2 pi n. Divide by 2 or multiply everything by 1/2, and you get 2 pi over 6 or pi over 3 again. And that'd be 2 pi over 3. Nope, just pi. N. All right, so that's 1. And the other one is your 2x equals 4 pi over 3 plus 2 pi n. Multiply everything by 1/2. 4 pi over 6 or 2 pi over 3 plus pi n. Oops, not this part up here, just this right here. So we have two answers here and here. Now that we've done all of that, one thing you should notice is that you could have distributed the sine of 2x times this here, could have distributed cosine of 2x times this. What happens is you only get these answers and these answers. You do not get these. So there is a difference here. If I would distribute, this becomes 1, and this minus 2 times the sine of 2x. So look down here, I'll write this real quickly, and then we'll move on. If I distribute that there, the sine of 2x times the cosecant of 2x, which is 1 over the sine of 2x, minus the sine of 2x times 2, if we're distributing, this becomes 1, and we have 2 sine of 2x. And there you get basically what we have in the position right here after you change everything. All right, so let's move on. Now, cotangent plus cotangent squared. So they both have cotangents. It's not a trinomial, so you're not going to factor that, but we can factor a cotangent out, and you get, oops, that should be 1 plus cotangent equals 0. So there's your A and your B. So cotangent of x equals 0, or 1 plus cotangent of x equals 0. So where is x over y equal to 0? So where is x 0? Because x has to be 0 for the whole thing to be 0. X is 0 at pi over 2 and 3 pi over 2. So we have pi over 2 plus pi n. Right? And then this one, subtract 1. Where's the cotangent of x? Negative 1. So x over y equal to negative 1. So again, you have square root of 2 over 2, square root of 2 over 2. That gives you 1. So your pi over 4s, but it has to be negative. So negative, either the top is negative or the bottom's negative. If the top's negative, then you are over at 3 pi over 4. If the bottom's negative, then the y value is negative, and x is positive. You're 180 degrees the other way at 7 pi over 4. So either way, it's 3 pi over 4 plus pi n. And those are your two answers. Okay, so now on 38, again, it's the same type of thing. Take a tangent out, you get 1 plus tangent equals 0. So where's the tangent of alpha equal to 0? Meaning y over x equals 0, so y has to be 0. Where's y equals 0? At these positions. So this is just going to be pi n, and 1 plus tangent equals 0. So where's the tangent of alpha equal to negative 1? Again, square root of 2 over 2 and square root of 2 over 2. So that's your y and your x. It doesn't really matter, but it has to be negative. So negative meaning y over x in those positions. So that'd be 3 pi over 4 plus pi n. All right, so those are your two answers for number 38. 39, the cosine of the natural log of x. Oh my goodness, so we're just going to say that's beta. So where is x equal 0? X is 0 at pi over 2 and 3 pi over 2. So now you have the natural log of x equals, that's going to be pi over 2 plus pi n. So this is log base e of x, so we're going to say e to the pi over 2 plus pi n equals x. And that would be your answer. Number 40, that's beta. So where does the y value equal 0? Y is 0 at these positions. So again, that's just pi n. Okay, so what do we have? The log of x equals pi n. That's base 10, so 10 to the pi n equals x. And that's your answer. 41, log base 10 again, that's beta. Oh, so we got to change it back. So that'd be 10 to the 0 equals the cosine of x. Remember, counterclockwise circle. So where does the cosine of x equal 1? Positive 1, which is right here. Every 2 pi. So this is just 2 pi n. That's your answer for 41. Here, e to the 0 equals sine of x. And again, anything to the 0 power is 1. So where is the y value? Positive 1. Right there, pi over 2. So this would be pi over 2 plus 2 pi n. And that's those sets of problems.